Welcome back to Nick Does Maths. We're going to do some complex locus in the complex plane with complex numbers and transforming, i.e. transformations of loci in the complex plane. So what do we got? We've got a locus that satisfies this relationship. Now looking at this, this is the distance from z to a point is equal to the distance from z to another point. That will be a straight line. All right, that is a straight line. And then it's transformed by the function kz plus I, k belonging to R. The image traces, once you've transformed it, you get a line y equals 2x minus 8 in the Cartesian plane. What value of k will make that happen? All right, let's find this out. So the first thing we probably want to do is, let's set this up. So our new variable, I'm going to call w because I am that level of creative, and we're going to rearrange it for z. We can then take that and plug it into my locus. W minus I over k plus 1 plus I is equal to W minus I over k minus 1 plus 2I. Right, now, if we set this up where w is u plus iv, what is the modulus of that? Well, the real part will be u over k plus 1 plus the imaginary part will be v minus 1 over k plus 1 all squared. Is that right? Yeah. Now that's got to equal, what's the real part of this going to be? Well, I'll get a u over k minus 1 squared. And the imaginary part will be a v minus 1 over k plus 2. And then we're going to square all that. Right. Now we need to shake this all around, do a bunch of algebra, and see what the relationship between u and v is. Now, one thing we're going to notice, if I expand this, I'll get a u over k squared, I'll get a u over k squared. They will cancel out. We'll get a 1 squared, they'll cancel out, so that's nice. So what am I left with from this one? I'll get a 2u over k plus, and I'll get a minus 2u over k. Just cancelling out the bits of these that will cancel out. Right, same sort of thing happens here. I've got a v minus 1 over k, which will get squared, a v minus 1 over k that will get squared. They will cancel out. So I'll end up with a 2v minus 1 over k, and I'll get a plus 1. And here I'll end up with a 4 lots of v minus 1 over k, and I'll get a plus 4. Right. Let's times everything up by k, bring that over to this side. So let's bring that over and multiply everything by k. So I end up with 4u is equal to, now I've got 4 lots of v minus 1, take away 2 lots of v minus 1. So that will be 2 lots of v minus 1 plus 3. K plus 3k. I've multiplied everything by k from going to there to there. So v is my y, so let's make v the subject. So 2v is equal to 4u plus 2 minus 3k. So v is 2u plus 1 minus 3 over 2k. Right, so this is respecting that relationship, right? V is my y, 2x, 2u. So I possibly could have done all of this with x's and y's, but once I've used w, u and v feels more right. It feels right, you know? But I need this to equal 8. So we need 1 minus 3 over 2 to equal 8. 1 minus 3 over 2k to equal to 8. That looks terrible. I got my minuses wrong here. Have I? That sounded very whiny. Oh, -8 has got to equal to -8. That's what didn't ring a bell. -8. So I get 9 is 3k over 2, which tells me that k is equal to 6. Lovely. Nice bit of complex transformations in the plane. That is completely algebraic. Very, very, very nice. We could possibly have had a little look at this in terms of transformations of graphs. Maybe one for another day. Wicked. So that's all we have time for. If you are enjoying the content, do check the link down in the description for this video, because we are running cram courses going into the exams. That means that the night before your further maths exam, you can hop on and live. We will be doing maths for 5 hours straight, going through exam style questions, boosting your confidence, making sure that you feel ready for the exam the next day. Like I said, all the information is down in the description of this video. Go check it out. If you sign up, we will also throw in revision, the same cram course for Maths A level for free as well. So go check it all out. In the meantime, I'm Nick, this was Some Maths, and I will see you next time.